Hello student. So based on our previous discussion, I have made or I have formed this table. Okay, so see the table. So this following table shows the slope, magnitude and phase angle values of the terms present in the open loop transfer function. Okay, and this data is useful while drawing the Bode plot. So we have already discussed when if we have constant term. Okay, so type of term is constant. If we have constant term like our open loop transfer function g j omega h j omega have k term, that means constant term, that the slope of that constant term is 0 dB per decade and magnitude is 20 log k and phase angle is 0 degree. Okay, so for if we have constant term, then our slope start is 0 dB. Okay, slope is 0 dB and magnitude is 20 log k and phase angle is 0. Now if we have 0 at origin, okay, that means if we have j omega, that means 0 at origin, then our slope is plus 20 dB per decade, then magnitude is 20 log omega and phase angle is 90 degree. Okay, if we have n zeros at origin, that means g j omega h j omega equal to j omega to the power n, then our slope is 20 into n dB per second, n dB per decade, and magnitude is 20 into n into log omega, and our phase angle is 90 into n. Now see, if we have pole at origin, that means g j omega h j omega equal to 1 by j omega, then our slope will be minus 20 dB per decade, magnitude is minus 20 log omega, and phase angle is minus 90 or 270. Okay. If we have n number of poles at origin, then that means if g j omega h j omega equal to 1 by j omega to the power n, then our slope will be minus 20 into n. Magnitude, in that case magnitude will be minus 20 into n log omega dB, and phase angle is 90 minus 90 into n or 270 into n. Now if we have simple 0, that means g j omega h j omega is equal to 1 plus j omega t. Okay, then our slope is plus 20 dB per decade and magnitude 0 for omega less than 1 by r and 20 log omega r for omega greater than 1 by, this is not a, this is tau. Okay, so 0 for omega less than 1 by tau and 20 log omega into tau for omega greater than 1 by tau, and phase angle 0 for omega less than 1 by tau and 90 for omega greater than 1 by tau. Now if we have simple pole, so if we have simple pole, that means g j omega h j omega equal to 1 by 1 plus j omega tau, then that case our slope will be minus 20 dB per decade. Okay, and magnitude is 0 for omega less than 1 by tau and minus 20 log omega tau for omega greater than 1 by tau. Okay, and phase angle is 0 for omega less than 1 by tau and minus 90 or 270 for omega greater than 1 by tau. Okay, Now, if we have second order derivative term, that means if we have gg omega hg omega like this, that means omega n square into 1 minus omega square divided by omega n square plus 2 zeta j omega divided by omega n. In that case, our slope will be 40 dB per decade and magnitude will be 40 log omega n for omega less than omega n and 20 log 2 zeta omega n square for omega equal to omega n and 40 log omega for omega greater than omega n. And in phase angle, in the case of phase angle, 0 for omega less than omega n, 90 for omega equal to omega n and 180 for omega greater than omega n. Okay, so whatever we have discussed in previous lecture, I have formulated all this in this table. Okay, so remember this table when you will plot Bode diagram. Okay, thank you.